All right, today we're diving into something that might just flip your understanding of cancer on its head. It's a fascinating new hypothesis that takes a completely different look at what this disease actually is. You know how we always talk about cancer? We call it this cunning monster. We're fighting a battle against a smart enemy. But what if that's all wrong? What if we've been giving it way too much credit? Well, that's the core idea from a really interesting paper by David DeVault. He's proposing that cancer isn't some complex mastermind. Instead, think of it as a biological glitch, just a messy, inefficient machine that's stuck on repeat, following a few simple, predictable rules. Okay, and a super important disclaimer right up front. The paper itself is very clear that this is not medical advice. It's a conceptual framework, an invitation to just think differently about the problem. So let's keep that in mind as we go. All right, so with that out of the way, let's put on this new lens. How does it completely change the story we tell ourselves about cancer? So let's break this down. On one side, you have the way we usually see it. Cancer's this brilliant strategist, always one step ahead, evolving to beat our treatments. But this new hypothesis, it says the exact opposite. It's a dumb, chaotic machine just making copies. It's not evolving on purpose. It's just making a ton of mistakes, and hey, some of those mistakes just happen to work out for it. To really get a handle on this idea, the paper uses a pretty powerful analogy. It asks us to think about cancer's behavior as if it were a mindless parasitic virus. And when you look at it this way, the parallels are kind of wild. I mean, think about it. Like a virus, it's a totally selfish replicator. All it wants to do is make more of itself. It hijacks our body's systems, our blood, our metabolism, for its own gain. It mutates like crazy, so much that its own genetic code starts to fall apart over time. It doesn't have some brilliant plan to trick the immune system. It just overwhelms it, wears it down. And here's the kicker. It has zero long-term strategy. It's so focused on growing that it ends up killing its host, which, kills itself. Not exactly a master plan. Now, we've got to be super clear here. This is an analogy for its behavior, not what it is biologically. Of course, cancer is not a virus. It's made from our very own cells. You can't catch it from someone. And this is interesting. We do see some mutations that pop up over and over again, which suggests there are some predictable ruts it falls into. And this picture really drives the point home. The idea here is that the tumor isn't some military general planning an invasion. No, it's more like a clumsy plumber, just mechanically tapping into the host blood supply wherever it can. It builds these connections to steal resources, not out of strategy, but just because that's what the mechanics of its growth allow it to do. Okay, so if cancer is just this chaotic, wasteful system, then where's the glitch in the matrix? What's the hidden weakness we can actually go after? This new way of thinking even reframes the scariest part of cancer, metastasis. We think of it as a planned invasion, right? An army spreading out to conquer new territory. But this model suggests it's more like a leaky pipe, just mechanical leakage. Cells flake off, tumble around randomly in the bloodstream, and most of them die. Only a tiny fraction happen to land somewhere they can actually survive. It's a lottery, not a military campaign. This is a fantastic illustration of that leakage idea. Think about prostate cancer. A lot of the time, the tumor is literally stuck inside a physical container, the prostate capsule. It's not clever enough to figure a way out. The real danger is when it grows so much that the pressure builds and the container just bursts. And that totally supports this idea that containment is a huge part of the puzzle. And that brings us to the core glitch, the big secret weakness. What we think of as cancer's greatest strength, that insane, rapid growth, is actually its fatal flaw. It is a ridiculously wasteful system. Think of it like a souped-up engine with a massive fuel leak. It's a metabolic gas guzzler that's always on the brink of stalling out. So, if that's its weakness, how do you exploit it? Well, this leads to a totally different strategy. If you're dealing with a hungry, inefficient system, maybe you don't need to blow it up. Maybe you just need to cut off its fuel supply. And this chart here shows us exactly what's on the menu. Just look at that massive slice for glucose, sugar. That's its #1 fuel source. Its whole system is ridiculously dependent on it. And that massive appetite for sugar, plus its need for things like oxygen and amino acids, well, that creates some very clear targets. So the strategy that emerges is all about nutrient denial. You can try to block the pipes it uses to get fuel. You can mess with its ability to use different kinds of fuel. You can even feed it counterfeit nutrients to clog up the system. And through it all, you focus on keeping the host, the patient, strong and healthy. The whole goal isn't a frontal assault. It's to gently but firmly push the system into a controlled collapse. And this is where something like diet could potentially play a role. The paper talks about things like fasting or keto diets, and the idea isn't to starve the patient, not at all. It's about putting a very specific kind of metabolic pressure on the tumor, stressing out its inefficient engine while our healthy cells, which are much more flexible, can adapt just fine. Okay, let's pull back for a second. Why does any of this matter? I mean, it's a hypothesis, a different way of thinking. What's the big deal? Well, it's a huge deal, because how we frame a problem changes how we try to solve it. A new perspective opens up entirely new toolkits. Suddenly, researchers can look at a tumor like an ecologist looks at a failing ecosystem. Our treatment goal can shift from all-out attack to containment and collapse. And maybe one of the most powerful things is what it does for patients. It can help reframe cancer from this terrifying, all-powerful monster into something more understandable, a flawed, predictable system that has weaknesses we can actually target. The paper really boils this whole idea down to one single, powerful line. The goal isn't to kill it smarter, it's to let it die. And that leaves us with one last big question to think about. In this huge, complicated fight to understand cancer, could it be that our most powerful tool isn't a new drug or a new machine, but simply a new perspective?